So the problem is there's a curve which whose x coordinate is defined as x equals a, where a is a constant, times theta plus sine theta, and whose y coordinate is defined as a times 1 plus cos theta. Alright, and they are asking us the slope of this function, you can say, at theta is equal to pi by 2. So what is the slope there? We all know that the slope is defined as dy by dx, right? So you can see that this cannot be done directly because y is not a function of x, but it is a function of theta. So what do we do? So I'll give you a little hint here. You can kind of view these differentials as fractions. Okay, so you can multiply, divide by d theta here. I'll just bear with me. I'll explain this. So if you do a little rearrangement here, you will get that this is dy by d theta whole upon dx by d theta, right? Just the d thetas will cancel, and you'll be back where you came from. So what is why did I do that? Because this doesn't make any sense, because yeah, I'll just explain you. I did this because y is a function of theta, right? So dy by d theta is pretty easy to find. I'll just differentiate this equation and I'll get dy by d theta, and similarly for dx by d theta I'll differentiate the first equation, and when I take the ratio I'll get the slope. So that's pretty much it. That's it. Actually, there's nothing more here. So I'll just do it for you. So dy by d theta is what? If you differentiate this, you'll get a minus a sine theta, right? Yeah, and all of that divided by dx by d theta, which is the differentiation of this equation of x with respect to theta, and that'll get you to a into 1 plus cos theta, right? So this will simplify to what? This will simplify to sine theta, actually minus sine theta upon 1 plus cos theta. Okay, and they are asking us that what is the slope at theta equals pi by 2. So we'll just substitute pi by 2 here, and we'll get the answer. So what is the slope then? The slope is simplified to this thing, but when you put pi by 2 instead of theta, you'll get sine of pi by 2 is 1, right? So there will be negative 1 upon 1 plus what is cos pi by 2, right? If you view the unit circle, that's a horrible one. So at pi by 2, the x coordinate of that point, or I'll draw a better one. So when you go to pi by 2, the x coordinate of the point where you are is 0, right? So the cosine of that point is 0. So what does this, where does this get us? Well, this is nothing but minus 1. So there you go, that is our answer. So you can kind of view this as implicit differentiation, but this is not kind of implicit, but this is what is called parametric equations, right? So theta is a parameter here, because to visualize that, you can take the example of if you've done kinematics, then you'll know that the displacement is something blah 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 into t plus something blah 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 into t squared, right? And actually in the y direction, actually no, not necessarily. Okay, that is in the y direction, you can say, because there's gravity in the y direction. And in the x direction, the displacement is something blah 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 into t, right? There's no acceleration term here because in the x direction there's no acceleration. So you can see that y is defined in terms of t, where t is a parameter. That's what it's called. It's kind of a third variable or an extra variable that you define to just keep things simple. And x similarly is defined as something blah 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 into t. So that is also parametrically defined. And one thing you can see that I could have eliminated theta, right? Because I could have brought this a down, subtracted 1 and take the cosine inverse of both sides, but that is not the best way to do it. You'll get the answer, but this one is kind of fast, right? And so I'll just summarize it, the problem for you. So what did they ask us? They asked us the slope of this function at theta equal to pi by 2. So we knew that the slope is dy by dx, right? The change in y upon change in x. And we had y as a function of theta and x also as a function of theta. So we didn't want that. So what did we do then? I'm sorry about that. I don't know why I can't. So we kind of viewed this as multiplying by d theta by d theta, because this kind of cancels to give you 1. So you're multiplying by 1. But the advantage that we get is we can write this expression as this, right? And that it kind of tells us that you have to evaluate dy by d theta, you have to evaluate dx by d theta, and you will just have to take the ratio of both of them to get the slope as a function of theta. So we differentiated this function, and we divided those, and we got the slope to be minus sine theta upon 1 plus cos theta. And because they asked us the slope at pi by 2, we just substituted pi by 2 in that formula, and we got slope as -1.